This presentation is about rationalizing the denominator. By the end of this presentation, you should understand how to do this and I suppose the benefits of doing it. So why do we rationalize the denominator? There are certain standards that your fractions should meet as an end solution. So in the past, we've only ever looked at your solution being in simplest form. So if you had 5 divided by 30, your result would have to be 1 divided by 6. We are now making this, I suppose, one more step fussier. What we don't want is to have a surd on the bottom of the fraction. So the denominator of a fraction should not be a surd in your end answer, or should not contain a surd in your end answer. The process of removing the surd from the bottom of a fraction to the top is called rationalizing the denominator. So how to do this? Alright, when we go to do this, you need to recall some special properties from when we multiply some surds. So recall that if you multiply two surds where the numbers are exactly the same, so root 8 times root 8, you would get root 64, which is 8. So multiplying a number by itself will actually result in removing that surd, that bracket. The other multiplication you need to remember is that conjugate multiplication, so where we switch the sign inside from minus to plus or plus to minus, but the numbers or the surds don't change. So these two here are conjugate pairs, and when we multiply conjugate pairs together, we always get out a rational result. So two scenarios you need to be able to recall in order to be able to rationalize our fractions. So some examples. Example 1 is just looking at a single term on the bottom of a fraction, so root 4 for instance. The method to do this is to multiply the bottom by root 4. So we've got root 4 on the bottom, we want to get rid of the surd, so we multiply the bottom by root 4. Now if you multiply the bottom of the fraction by root 4, you must do the same to the top. This is essentially multiplying 3 root 4 by 1, because root 4 divided by root 4 is 1. So I haven't changed the value of this fraction, I've just manipulated what it looks like. So when I expand this, I get 3 root 4 on root 16, and we know that the square root of 16 is actually 4. Now that's not my most simplest form, and we'll look at that in the calculator in a second. Missing something very obvious about square root of 4. But we'll look at the second fraction first. So we've got x divided by 3 root 5. I again want to get rid of that root 5. I don't like root 5 on the bottom of a fraction. So just like before, I multiply top and bottom by whatever that surd is. So the surd is root 5. I multiply top and bottom by root 5, which is essentially multiplying by 1, which is what this is here. When I go through and do this, I get x root 5 and 3 root 25, which is the same as 3 times 5 or 15. This is my end result. Now I can check these on my calculator, right? I just basically type it in as is. So I can type in 3 divided by root 4, and this is where we pick up the fact that my solution is not its most simplest form. So I'm going to quickly change that. So root 4 is the same as 2, so 3 times 2 divided by 4, which is 6 divided by 4, or 3 on 2. I can also do the second one, so x divided by 3 root 5, I press enter, and it gives me out the correct result that's there. So your calculator will do these simplifications for you. The reason why we're doing this by hand is A, so you can learn the process so you can do it by hand, but also because when you're given multiple choice questions, you might be given a solution that's not exactly what the calculator has or what you would get originally by hand. So it might be one of the intermediate steps. Example 2 is looking at something a little bit more difficult. You multiply top and bottom by the conjugate pair. Because the bottom is not just a surd, I can't just multiply this by root 2. If I did that, my solution on the bottom would have a 3 root 2 in it, which isn't what I want. So I'm going to have to multiply by the conjugate pair of the denominator in order to get rid of all the surds off the bottom. So multiply top and bottom by the conjugate pair. when we go to do this, we need to recognize what that conjugate pair is. So we're going to have 3 minus root 2, and the conjugate pair to that is 3 plus root 2. So, multiplying. Just like before, what you do to the bottom, you must do to the top. So I'm going to have 3 bracket 3 plus root 2, and then on the bottom 3 minus root 2, 3 plus root 2. Expanding the top, you can sometimes maybe not expand the top. I've chosen to here. And also then applying the distributive property on the bottom. Going through this, I get 9 plus 3 root 2 minus 3 root 2 minus root 4. Again, noticing that property, middle two terms are going to cancel out. End term is equivalent to 2, so that's quite nice. So when I go through and do this, I'm actually going to have 9 plus 3 root 2, and then 9 minus 2 on the bottom, which gives me this is my end solution. So 9 plus 3 root 2 divided by 7. Note the denominator of my fraction has no surds in it. So it is rational, and I have rationalized the denominator. I've got to my end aim. Another example. Oh, we can check this on our calculator, sorry. Again, I'm just typing in like normal, and it pops out with a solution. This solution is exactly the same as what I've got here. Expand the top in your bracket, and you'll have out the same solution as what I've got. Alright, next example. So, again, I've got a scenario here where on the bottom of my fraction I have 4 root 12 plus 5 root 11. 12 is not in its simplest form. I could, however, still just find a conjugate pair of this without simplifying it. I'm going to choose to simplify it to start off with though. So 4 root 12 is the same as 8 root 3, sorry. And then the conjugate pair of that is going to be 8 root 3 minus 5 root 11. Just like before, multiply top and bottom by the conjugate pair. So the conjugate pair is 8 root 3 minus 5 root 11, top and bottom, which is the same as multiplying by 1. Apply the distributive property to the bottom of the fraction, and you're going to get out quite a large, well, a large sum, let's say. So 64 root 9 minus 40 root 33 plus 40 root 33 minus 25 root 121. Just like normal, the two middle terms cancel out, and the first and last term can be simplified to have no surds. So this is going to give me, on the top, still, I can simplify that, yes, so 18 is the same as 9 times 2. The bottom is going to be quite a large number. We'll just chuck that into the calculator in a second. To give a result of negative 83. That there is potentially as good as it gets. There is another sort of rule for fractions. It's not a hard and fast rule, but we tend not to leave a negative on the bottom of a fraction. So probably moving that negative to the top. So let's just make it 5 root 66 minus 24 root 2. It is the same as what the previous answer was. It's just written differently, I suppose. Check that into my calculator. So put the original question into the calculator. The result that the calculator is going to give me will actually look very slightly differently. It's going to split it into two separate fractions. Those two separate fractions, though, are actually the same thing. We've got 83 on the denominator and 83 on the denominator. So one fraction with 83 on the denominator. It's exactly the same as what they've got. 5 root 66, 5 root 66, a minus in the middle, and then 24 root 2. So they've got the same result as what we've got, but again, they've just written it very slightly differently, and that's fun.